Well, greetings, Mr. Kolazar's class. Our last section of Chapter 5 on the back page of the packet is on Lewis structures. And what we're going to be looking at today, you'll need to have your notes out and then also grab your Chapter 5 worksheet out, or Chapter 5-4 worksheet out. You'll be using this shortly, so have both of those available when we get started. So what we're going to look at today is the idea of our outer electrons. Now, our outer electrons are going to be the electrons that are responsible for most of the chemical properties. One of the terms we're going to look at as we're going are valence electrons is going to be a term coming up that we use all the time. This term valence electrons are talking about the outermost energy level electrons. So whichever electrons are in the last energy level are going to be the ones that we're going to be concerned most with. So in our Lewis structures, those outer electrons are going to be the ones that are shown. So they show the outermost electrons, and they're going to be electrons shown with dots. A lot of times you hear these as electron dot diagrams. Now what we're going to look at is we're going to have a couple rules. First off, if we have two electrons, the first two electrons are going to be paired to the 12 o'clock placement. 12 o'clock, if you're thinking about the clock, you know, we have 12, 3 o'clock, 6 o'clock, and 9 o'clock, just so we get those placements down, paired together at the 12 o'clock. If we have more electrons, we're going to place them as singles, the next three, at the 3 o'clock, 6 o'clock, and 9 o'clock placements, and then they're going to be paired up 3 o'clock, 6 o'clock, and 9 o'clock placements. The maximum amount of electrons that can be in the outer energy level we're going to find out is 8. So after 8 we open a new energy level, and at that point we get new valence electrons or new energy level where the electrons are at. So we'll have between 1 and 8 electrons in that outer energy level at any one time. So just as an example, X would be just any element. So if we have X as our element, if we have one outer electron, it's going to be placed as a dot above that element, that whatever symbol we've given it. If there are two electrons, they'll be placed as a pair. 3 electrons, single, single, and single at the 3 o'clock, 6 o'clock, and 9 o'clock sides of that element symbol. And then if we have more, back at 3 o'clock, 6 o'clock, and 9 o'clock placements. So to look at those, this would be your first and your second electron. 3, 4, 5, 6, 7, and a maximum of 8 electrons can be in the outer energy level as we're going. The p orbital, or excuse me, the s orbital will be our first two, and then the next 6 are the p orbital. So to practice a few of these out, we've already seen hydrogen, H1, or one proton, so one total electron. So one, our energy level 1, sublevel our shape, S, and 1 electron inside of it. Since there's only 1 electron in the outer energy level, we just put 1 dot up on here. I don't think that problem's in your notes, but just to show that one. So let's move on to carbon. Carbon, 6 total electrons, element 6 on the periodic table, 1s2, 2s2, 2p2. So there's a total of 6 electrons for carbon. Now, only the second energy level, highest energy level, has 2 electrons and 2 in the p. Both of them are in the second energy level, so a total of 4 electrons. So as we're drawing that one out, we are going to see 1, 2, 3, 4 total outer electrons. So carbon has 4 valence electrons, or 2 paired to the top, and then 1 at 3 o'clock and 1 at 6 o'clock placements. Calcium element 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So as we're going, 4th energy level is the highest energy level, and there are a total of 2 electrons in that one. So those 2 electrons again placed at the 12 o'clock placement. So they're paired together up top for calcium. And then we'll go a little bit larger. Bromine, element 35 on the periodic table. 35 total electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 fills all the way up, 4p5. Now the trick with this one is 3d the inner energy level, 4, and we have our fourth energy level with the S and the P. So both of these are involved in the outermost energy level. And you got the largest number. So don't worry about the 3d10, just the 4p and the 4s. So we have a total of 2 plus 5 would give us 7 outer electrons that need to be shown for bromine. We pair the first two together at the 12 o'clock placement, single, 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 and pair, pair. And so in the end, bromine has 7 outer or 7 valence electrons. So now you're going to work on worksheet 5-4. On 5-4, as you look at those elements, the first 2 rows of elements are going to be elements seen anywhere between 1 and 20. Now after those elements, you'll be able to begin to see a pattern forming with the number of outer electrons in which group you're in on the periodic table. So as you're going to find out writing out the element symbol, and then from there writing out the number of outer electrons by looking through how many are in that final energy level. For about the last 5 or 6 problems, start using the periodic table to see the patterns you've seen with the first few elements. That's going to help you out on worksheet 5-4. Go ahead and start working on those problems now, knowing how to set up your Lewis dot structures.